This is a video on how to approach related rates in calculus. We'll start out with an example of a related rates problem. An 8-foot-long ladder is leaning against a wall. The top of the ladder is sliding down the wall at a rate of 2 feet per second. How fast is the bottom of the ladder moving along the ground at the point in time when the bottom of the ladder is 4 feet from the wall? This may seem a little confusing at first, but all you have to do is follow these simple steps. The first step is to draw a diagram. This will help you visualize the problem and figure out what variable you are asked to solve for. This diagram shows the 8-foot-long ladder leaning against the wall, but as it is sliding down, it is now 4 feet away from the wall. The second step is to specify the unknown rate of change and to record all other given information from the problem. Let y equal the distance from the top of the ladder to the ground, and let x equal the distance from the bottom of the ladder to the wall. This means that dy dt, which is the rate that the ladder is falling down, is equal to -2 feet per second. We are asked to find dx dt, which is the rate at which the ladder is moving away from the wall when x, this distance, equals 4. Step 3. Find an equation involving the given variables. In this problem, it is best to use the Pythagorean theorem, a squared plus b squared equals c squared, because the ladder forms a right triangle, with the wall. The equation x squared plus y squared equals 64 is always true because the ladder is 8 feet long. To find out what y equals when x is 4, simply plug in 4 for x. 4 squared plus y squared equals 64. The final answer is that y equals the square root of 48 at the time when x equals 4. The fourth and final step is to implicitly differentiate the equation with respect to time. When you take the derivative of x squared plus y squared equals 64 with respect to time, you get 2x dx dt plus 2y dy dt equals 0. Now, plug in the rate of -2 feet per second for dy dt, and you get -4y. In the following step, solve for the rate that x is changing to get 4y divided by 2x. To calculate the rate at which x is changing at the point in time when x equals 4, plug in the values of x and y into the equation at that point when x equals 4. You found this value from the previous slide. The final answer should be 3.464 feet per second. Remember to always specify the final answer with the correct units. Now that you know how to properly approach related rates problems, calculus should be easier. Good luck! This explanation video for related rates was created for the website BAM! Which, if you haven't figured out already, stands for the names of the 3 creators of this wonderful website.